Hey builders, thanks for choosing to hack with Ethereum Attestation Service. The purpose of this recording is to help speedrun your education around what EAS is and really help you understand a lot of the tools and resources that are available to you to help you get hacking as quick as possible. So EAS is an infrastructure public good for making attestations on-chain or off-chain. Ultimately, attestations are going to help us build more trust in all of our online interactions. And we'll explain kind of why that's important and how we got there. One of the important key things to note is that EAS is completely open source. We're permissionless, tokenless, and free to use. We were really excited about digital identity, and we kept asking ourselves, why hasn't anyone been able to solve it? It's a very complex problem, but incredibly important because digital identity can unlock so much. And there's no shortage of apps that are trying. And as we look throughout the ecosystem, we notice how completely fragmented everything is. So as developers, we have a never-ending list of protocols we have to learn. So WorldCoin, Gitcoin, Proof of Humanity, Sysmo, Spruce, POET, the list keeps going on. And we realize that none of these protocols are talking together. So we thought, well, what actually is identity? And so we went through this thought experiment and we were starting to question, well, what was our first identity? Maybe all these protocols and all of the builders are just built, maybe we're all building one layer too high. And so we realized that at one point in our lives, we didn't have an identity, and then we did. And we realized that our first identity is actually when our mother names us, right? It's when she attests to our name. And then throughout life, other entities started attesting to different aspects of who we are. Like the doctor attests to your date of birth, your school attests to your grades, the employer attests that you work there, friends attest that they like you, and the list goes on and on. And so what we realized is you can actually elegantly represent identity as an aggregate of these attestations over time. And we don't aim to replace identity protocols. EAS aims to enhance them and to make the ecosystem more interoperable by giving all of us a base layer to start making claims about anything. Attestations can help us go beyond identity as well. Anywhere you need proof or verification that an entity said something for trust and verification, that's where attestations can play a pretty critical role. So we have teams building around voting systems for transparent voting. You can build things like content authenticity platforms to attest to the authenticity of content by creators, marketplaces, proof of provenance, compliance, related things, registries, digital notaries, oracles. We have a full use case doc in our docs page that can help inspire if you're looking for some ideas. But ultimately, anywhere you need to prove trust or verification around some sort of structured data, that's where attestations are going to be helpful. Our feedback and traction has been pretty awesome. Optimism was building their attestation station, and they ended up deprecating it to upgrade to the EAS standard, which was a huge vote of confidence just for the ecosystem around attestations, as well as for EAS becoming a standard. DevFolio, another hackathon team, has been actively using it for their hackathon for quadratic voting, where people actually attested to the vote of the projects that they wanted to win. We have identity protocols experimenting with it, and then just ecosystem people really recognizing the need for this credibly neutral public good, and that EAS potentially has a shot to helping us get there. EAS is super simple in terms of the infrastructure and how it works. It took us a while to get there. However, understanding it is relatively easy. It runs on 2 smart contracts, one for making a schema about any data structure for the attestation. So imagine if you wanted to attest to an event attendance, you might have like an event ID, the location of the event, and then the time that someone checks in. And then the other contract is for attesting on that schema. So you register the data topic and then use the other contract for making attestations on that schema. If you want more control over the functionality of the schema, we have an optional resolver contract, which allows you to basically use any arbitrary smart contract logic tied to the schema, so you can prevent people from making attestations, send a payment, and do a lot more from there. We built several tools to help you. So our whole focus is on making the dev user experiences world-class. So we built a lot of things like an attestation explorer, an SDK, GraphQL endpoints, and a lot of other things really to help you get up and going as quick as possible. So let's jump over to some of them. This is basically the Ether scan of attestation. It's called EAS scan. We are live on, if you go to the chain selector, we're live on mainnet, Arbitrum, Sepolia, Optimism, Goerli, Base. We're also on Optimism Bedrock. By the time you watch this, it'll be available. And when you go to the Explorer, you can start to explore some of the schemas that have been created. So you can start to get an idea that schemas can be really any type of topic. So this is a schema for attesting to a hackathon, which is just like a registry, more or less. You have a string name for the hackathon, the location, if it was virtual or not, the start and end date. You have other people looking at like event attendance. There's people creating schemas around identity-related stuff, authorizing payments and funding requests, more identity stuff, so you can start to see what's available. Now, you might say, hey, I want to create my own schema. We built some pretty easy tools where you can just start to create your own structure. So you might have, let's just use the event attendance as an example, an event ID, and that's like a bytes 32 field. So you can pick the data type here. Maybe it's like the location. You have like a string. Maybe it's a check-in time. And you have, a number, UN64 or something like that for a time. And then you can designate the resolver address and decide if you want attestations made at the schema type to be revocable or not. So, and then you can make it. Once it gets registered, it'll show up in the schema registry. Let's go into this hackathon one. So here's the schema record. It's for hackathon. You see the unique ID here, when it was created, who the creator of the schema was. And one key thing to note is the schema doesn't matter as much as who the attester is that's using the schema. So imagine if I'm wanting some sort of KYC verification. If I were to attest to someone, that doesn't mean anything because I'm not a KYC verifier. But if someone else were to, like a KYC verifier were to attest to that person with a KYC attestation, then that holds more weight. On this schema record, you can see the decoded data and any related attestations of this schema type. So we have hackathon location. Let's click into this one. On the attestation record, we can see the UID, the schema that was used, who actually made this attestation, the hackathon related data that was attested to, and then if anything was referencing it. Every attestation has its own unique ID, which is a hash of the entire attestation. And you can also see if this attestation is going to expire or if it's been revoked. If you were the issuer of this attestation, you'd have an ability to manually revoke this attestation, which is pretty powerful and useful. Let's actually create one so you can see how this works. So in addition to this on-chain attestation, we also created an ability for you to make off-chain attestations. So we'll make post. Let's actually do a post. Make a statement. So this is a very simple schema. It's just a string with a message. So and then you can see all the related ones down here. So let's attest with it. You don't have to designate a recipient, but you can if you want. And then whatever the decoded data was per message string, so we could say, looking forward to all the global Waterloo hack projects. This wouldn't expire, and you can reference an attestation. So just like how we had the attestation for the hackathon here, we could go into the attestation record, grab this UID, and if I wanted to reference this, saying, hey, this is related to that hackathon attestation, I could do that. So we'll make this attestation on-chain. Actually, we'll do this one off-chain because we just saw an on-chain one. So this is just a EIP 712 signature. We're signing it. And now we have a completely private off-chain attestation. It's not stored anywhere. It's actually fully encoded in the URI fragment of the URL. And the UID is the entire hash of the attestation. And so if you were to scan this QR code, it actually will decode everything and show you in the browser. One of the key things related to off-chain attestations is that they don't have proof of existence because they're not, there's no block time and there's no on-chain verification of this. And so we actually created a way for you to timestamp the UID on-chain. So we'll actually do that really quick. We also built some ways to use Merkle trees to batch a ton of these off-chain attestations into one timestamp, which makes it super cheap to do this. What this does is it's giving this attestation proof of existence that the UID actually existed at this time. Couldn't have existed after this point in time. And so you can see down below, we have this reference attestation, which was the original. You can click on it and then it opens up, hey, here's the hackathon that this attestation is related to, but there's no, since it's a private attestation, you can see that there's no referencing ones there. Now, to take privacy even a step further, we built this thing called private data attestations, which is a very simple schema. It's a bytes 32 private data field. So it's just a hash. And what we did is we were wondering, like, well, with ZKPs right now, there's no standardization and everything seems to be very application specific. So we're wondering, I wonder if there's a way where we could attest to private data, but then allow users to selectively disclose it. And so we found a way to do that using Merkle trees. And so let's explore an example. Let's say Steve, let's say I'm a verifier, like a KYC person or some sort of like identity verifier. I want to attest to some private data about Steve. So the recipient, Steve, and maybe I'm attesting that his full name is Steve Dack. His title is CTO, maybe something more private like his social security number, right? Maybe his like home address. And then maybe there's like some computed value. It could be any arbitrary value, but that he's over 21, true. And I want this verification only to last for, call it the next, month. And then I want it to disappear. Well, I can make this on chain and someone might think, well, I don't want all this data to be on chain, but what actually goes on chain is just the Merkle root hash. So we're attesting to this. And as this Merkle tree is generating, every data field that gets created is being hashed and then hashed together and hashed until we have ultimately a Merkle root. And so by generating this, you can see here's the new attestation record, when it was created, the expiration time, when it was revoked, who it was from and who it was to. And then all that was attested to is the decoded data here of the bytes 32 hash. This private data is in my local storage, so I can access this. Imagine if I'm Steve receiving it. But if I were to go to just a browser, a private browser, you can see here that the private data is in here. All that's on chain is actually the bytes 32 private data field. If I'm Steve and I wanted to share that, hey, my name is Steve and that I'm over 21, I could generate a proof instantly. It generates, and every field is completely, it's salted, so you can't brute force it, but I can grab this proof, come back over, paste it, and then if Steve provided these leaves to someone to verify against, he can click verify proof, and then you can see Steve's data gets verified against this Merkle root. Now, if you were to add in something else that wasn't a part of the tree, then it wouldn't verify. And you can continue to do this on, let's say, ultimately, he does want to share his title, that he is the CTO. copy this, paste it, and keep verifying different leaves against that. So pretty cool to allow users to selectively disclose private data using Merkle roots. And then to take this a step further, we're really excited about ZK projects that might generate proofs based off of attestations themselves and or some of the related data. Another cool thing that we built is the ability for creators to hash content and attest to it. So especially in the age of AI, with all this generated content, it's going to be increasingly important for people to attest to the authenticity of what they're producing. So imagine I am a podcaster or some creator with all these deep fakes happening. How can you actually prove the authenticity of your episodes or the content that you're creating? Well, you can do that by attesting to a hash of the content. And something to note here that EAS is not intended to be the UI for all these experiences. It's just meant to be a block explorer. But we did build these like helper kind of UIs just to help show people what some of the possibilities are. So imagine this is like with some really awesome content authenticity platform, but what you can do is if you grab some sort of file, I'm just going to grab like a image that I have. So here's an image that's in my local files. I can drop it. It generates a hash of that file. If one pixel change, obviously it would generate the same content hash. But what happens is if I'm a creator and this was my file, I can attest to it. And so we are attesting to the hash of this. And imagine if this was like a MP3 file or something. As a podcast creator, now anyone can see that, hey, this actually was the hash of my podcast file. But I just attested to this hash. If I were to drag in some other random file, like some random QR code image, it's not going to verify against the hash. But if I were to actually drag in the right file, then it does verify. So this will allow people to see, hey, this creator attested to this hash of this content at this time on chain, and people can verify the authenticity of that file. One of the most powerful things with attestations is its composability using reference attestations. And so we built a pretty cool little demo of a social network based off of attestations, just to help show some of the composability. So I'm going to go over to it here. So this is an application called Speaketh or Speaky. And you can see that it just has a bunch of random posts from different addresses or people. So here's the sample post, GM, let's build from Steve. But what's unique is I'm going to scroll down to a post that has 3 replies related to it. And so we can see here's a post from Steve. It says the pending validator queue keeps going up. Down below, I can see a shield icon and click on it, and it goes to the attestation data. So we have this decoded data for string posts. It was from Steve at this time. And there's 3 attestations referencing this one. So if I look down here, someone liked this post, and then there was other posts related to it. If we go back to the UI, we can see that this post, there was 2 other related posts, and there's a like related to it as well. And as a creator, let's say I wanted to create a new post here, so we can actually do, excited for all the ETHGlobal Hackathon projects. I can create this. So we're just attesting to this. And what's cool is like what's happening is on the EAS scan, we're attesting to this data on chain, and there's private ways to do it and civil resistance related to social networks and stuff that can be explored. But the composability and some of the UI control is what we're showcasing here. So as that attestation gets made, you'll be able to see that, oh, that was my content hash. You can see when the attestation is generated. So we can see when it gets generated. So here it is. So excited for all the ETHGlobal Hackathon projects. Now someone could go into the attestation record and see, excited for all the ETHGlobal Hackathon projects. But what's amazing here is if for whatever reason Speak-It, fails or dies, the attestation data doesn't disappear. People can compose their own UIs, and the creators that are attesting to their content or their posts or whatever it might be, their data will live on, and people can start to control the UIs around this stuff. So if you wanted to create some sort of social network that only displayed like political views, or maybe you wanted to filter out political views, that's all possible on here. And for deleting stuff, even though it's on chain, you could simply just revoke the attestation too. So here I am revoking the attestation, which isn't true. Very excited for all the hackathon projects, but just for showcasing an example, when you revoke an attestation, it disappears. One of the cool things also to note is that as people start, so here it goes, it's gone now. And then if we go to the post, it's revoked. People are starting to build like some pretty cool social graphs and stuff too. So here's a cool graph, which was created by one of the members of the Optimism team, where he was encouraging people to just attest to people he thought was cool. So you can see these different nodes or these clusters where this person received a lot of attestations coming into it and also sent them out for people saying that they're cool. But then you can see these like edge cases where these two people attested, or this person attested to someone, but they're not a part of any network. And now this is kind of a meme example, but over time, as more and more attestations are created, you can start to see like how people are clustered together, and you can determine what, how you trust that cluster or information related to your use case. So a lot of pretty amazing tools that you can leverage just even with EAS, the Explorer. But if you go into the docs page, we have a ton of information related to understanding more about EAS. We have an SDK that's available for you to use. Super easy to get started with. There's GraphQL endpoints for every chain, so you can really inspect and start to pull that data as you need to. And then there's a lot of tutorials on how to kind of extend attestations in unique ways. One of the more important ones to take note of is around delegated attestations. So if you want to decide who the payer is for the attestation, this method will allow you to do that. But feel free to kind of read more into it. You can also look at the private data references. We gave you some ideas on how to like save gas if you are testing on chain, and a lot of other just helpful docs. The use cases page, if you're looking for some inspiration for your project, we tried to draft a decent amount of just inspirational use cases that you can kind of pick and choose from. So as an example, for like content authenticity, gives you an idea of what the problem is, the opportunity, some examples, but it's really up to you on how you want to implement it. We're just trying to help inspire what might be able to be built. So really looking forward to seeing what you all build during this hackathon. We can't do this alone. Please come join us and build more trust online. If you have any questions, we'll be around at the event. We're happy and excited to work with you all on the best ways to implement EAS into your projects, and look forward to working with you all. So thank you all. We will chat soon.